Well, good morning, everybody. This is going to be a recording, those of you who have seen my Google Hangout posts and everything. You noticed that there's no live stream, and evidently YouTube does not want me to live stream for some reason. And every time I want to decide to go to stream on this, it's telling me to create a new stream, and then it tells me live streaming is not available. So with that being said, I'm going to create a little video here where it can help to reference some of the stuff we've been going over. Now to go through with stuff from yesterday, that stuff yesterday, if you hadn't seen, if you paying close attention to anything, one of the videos on there had some kind of music that evidently YouTube's algorithms decided to flag that for a copyright claim. So that there goes doing that. So I'm sure you're all thrilled. So with that being said, I'm just going to get right into just talking about the topics. This is what I was going to do today. So I'm going to try to just go through with what we're doing here. I will try to stay with the same time frame of things, but I just want to make sure there's something up there because this is just I've been fighting with technologies now for I don't know how long, for about a week and a half, 2 weeks. I have no clue, but it's just ridiculous. It's ridiculous sometimes because normally I'm good with tech. But contrary to what you seem to see on things. But with that being said, I'm going to get into this. This is dealing with in your packets, the packets that I referenced, which were if you pay attention to Google Classroom, so if you go to classroom.google.com, you will have I moved the posting about the Blizzard packets there, the new packets that I made that I referenced here. I put them as pinned to the top of the pages right here. So with that being said, there we go. So again, with that being said, I pin these to the top so that you can be able to reference these. Obviously, this is the same post on everybody's Google Classroom page. So you have your can't talk, your sixth grade, seventh grade, and eighth grade. So for this specific time frame right here, I'm going to reference the sixth grade one. And with that being said, if I reference that sixth grade Blizzard packet that I did, I will be going to topic 7. And just so if you remember on these are broken down into 8 topics. So there's 8 topics on this. Um, 8 topics to where it breaks down the curriculum that we were going through during classes into just there are, 8 different sections right there. So this is dealing with topic 7. So if you're looking through and you flip through, or it's down on this. It's page if you downloaded the PDF, it's page 29. Looks a lot worse than what it really is. But I'm gonna get myself off the screen right here and just gonna get right into this. So I want to kind of talk about this in turn. What we're talking about right here is dealing with area, surface area, and volume. So like area, surface area, and volume, and a lot of the terms that we were kind of getting into right around that time frame we were about to leave was dealing with. We all went to the board and we were drawing rhombuses and trapezoids, and then we were about to deal more. I know you deal more into the nets and all that kind of stuff, but when you look at like your vocab review, and I hope that this is kind of a not common sense, but I hope you can kind of use your process of elimination when doing this. That you can look at this and say, well, you were going to write the vocabulary term that best represents each item. So that best represents each item. So number 1 says the measure of the space this solid figure occupies. I would hope that you all would know that this is going to be volume. Volume. Volume is something that takes up space. It takes up space. You're filling your pool. You're putting water into your pool. That volume is taking up that pool. Okay, it's a three-dimensional type thing, 3D. 3D. It's not flat. It's not flat like number 2 here, to where it's what we would call a net. That is a net. Okay, I think you guys had done a little bit of that with, I believe, with Ms. Holden with that, with dealing with starting with the nets. We were going to get more into that, and then the world went crazy. Um, number 3. So number three. This figure right here. This figure right here has these 4 little marks right here. And what is that telling you? Those 4 little marks are telling you that the sides are all the same size. They're the same size on those. They're the same length. They're congruent. They're the same size on these. So when you look at this, and out of what you have left to use right here, the only one that really makes any particular sense, it's not a trapezoid, it's a rhombus. That's a rhombus. Rhombus. 4 sides are the same. If the figure was like this, where you have 2 very long sides and 2 shorter sides, then you would have a parallelogram, right? And then number 4. It's asking you, well, what is point A? What is point A in this figure? Point A in this figure is going to be what we call the vertex. Each one of these, like a 3-dimensional figure, let me get all the rest of this off the screen. If this point that it all comes up to, or the point here, or the point here, point here, or the point here, any of these points right there, any of these points are going to be vertexes. There are vertex. That is a vertex. Think of it as everything coming together. A vertex. A vertex is what you're going to be, is what that point is. And if you remember, just to kind of flow right through this, I'm going to give you kind of the gist of this here. When it says to describe how to find the area of the quadrilateral, use vocabulary words in your explanation. We were talking about this. I think this is almost one of the last things we were kind of talking about. But if you have a crazy looking figure like you see right here, there's no specific formula for doing this. I mean, there's no specific formula for doing this. But the idea that what you're trying to look at is to say, well, instead of, you can be able to cut this into and decompose this into figures that you do know. So as you see the dotted line that I traced across right there, I traced across that dotted line so to show you now, well, you can break it down into finding the area of the rectangle there, and then find the area of the triangle there. When you find the area of both figures, you're then able to, find them, add them together, and then that will give you your full-fledged area of that. Okay? Let me make sure I'm still going along with recording. Okay, cool. Hopefully that's making a little bit of sense with some of that stuff. So like in this instance, so we go down to 7. So now we're down into 7.1. We talk about finding areas of parallelograms and rhombuses. Now, I would hope that this is like the more easier part of this, just because of the fact that a parallelogram or a rhombus, to find the area of that is simply put, and it tells you, it's the area of the base times the height. Now the base times height is how you can create that 90-degree angle. It's how you create that 90-degree angle here. Okay, it's not this. It's not like this. The base and height is not the diagonal in this. You're trying to find the 90-degree angle, as you see here. So when you do that, and you find that the base is 4, so the base is 4, and the height is 9, 4 times 9 is going to give you 36 meters squared. So 36 meters squared on that. 36 meters squared. Okay? Since you saw one so we did this one here, so let's go to number 4. This parallelogram parallelogram, area, okay, has a base of 12 and a height of 8.5. Well, the area equals the base times height. The area equals the base times height. You're going to take the area and you're going to take 12 times 8.5 to find you what your, to find you what your 12 times 8.5 will give you 102. So when you do this, 12 times 8.5 is 102 feet squared. Always remember to have that proper, label, feet squared, on that, feet squared, because it's the proper method. That's the proper method of measurement right there. If you were to sit there and say, well, the area equals 102, if I were to tell you, I think you remember me telling you guys in class, if I said, well, if you come across an answer and you said, well, the area is 102, well, 102 what? 100, area is 102. It's like, you kind of look at this and say, well, all right, well, it's you have to have that proper method of measurement right there. So, 1 second right here. 1 second. But again, I mean, that's just kind of dealing with, that's kind of dealing with that there. So let me scroll down. Here. Again, we talk about triangles. We talk about triangle area problems. Triangle area problems. Again, these break them down nicely for you. Your area equals 1/2 base times height. And again, it works the same way like with the parallelogram right there. If you have a triangle that looks like this right here, if you have a triangle that looks like that, you have to be able to, you're going to have to be able to, find what creates that 90-degree angle. Again, that 90-degree angle right there. So if your base is 2 and your height is 5, 1/2 of 2 times 5. 2 times 5 is 10. 1/2 of 10 is going to be 5 yards squared. So number 1 would be 5 yards squared. Okay. If. So we've done a visual one here. We've done the visual. Let's get this off of here. So we've done the visual for number 1. Let's go to number 4, just like we did up above. If we have a base of 3.5 meters and a height of 6 meters, it's just filling in. It's called evaluating this formula here. Your area equaling 1/2 the base of 3.5 and then the height of 6. So if I take my 3.5, let's just do this. Let's take this. If I take my 3.5 times 6, it's going to give me 21. Then times your 1/2 or divided by 2, same thing works. Your area equals, and what did I just have here? It was 10.5. 10.5, yeah. Again, your area is going to equal 10.5 meters squared. 10.5 meters squared on that. Okay, again, these with triangle area problems, these area problems that you see right here, it's evaluating, it's just being able to, you're trying to find what is what here. Okay, so let's go to the fun part, the fun one here. Okay, now we're talking about trapezoids and kites. Trapezoids and kites. Let's do number 1. Number 1 right here. If you remember, now I'm going to try to write this to where it makes the area of a trapezoid equals base 1 plus base 2 divided by 2 times the height. Right? All that good, wonderful stuff. So if you were to continue this, and you were to say the area equals the base the base 1 of 6, so 6 plus 5, base 2 is 5, that are there are parallel to each other there. 6 plus 5 over 2 times your height of 11, what creates that 90 degrees. You'll be able to do it. So 6 plus 5 over 2, that means that your area is 11 over 2 times 11. And what you can do here, if I take 11 divided by 2, it's going to give me 5.5. I then take 5.5 times 11, and it's going to give me the answer of 60.5. 60.5, and the proper 60.5 centimeters, that's a meter, centimeters squared. So centimeters squared on that. Okay, so that's a trapezoid. And let me conclude here with talking about the kite. So talking about the kite. If you remember when we talk about a kite, here. The kite is diagonal 1 times diagonal 2 divided by 2. Simply put, diagonal 1 times diagonal 2 divided by 2. So our diagonal 1 is going to be, for number 4, it's going to be 4 plus 10. So it's going to be 14 times diagonal 2, which is 2 plus 2, which is 4, divided by 2. So if I take 14 times 4, it's going to be 56. 56 divided by 2 is going to give me 28. And your answer is 28 inches square. 28 inches square for number 4. Okay. Guys, I hope that helps a little bit. Please, let me clear this off here. Please let me know if there's any questions. That's those first 3, we really did a lot of that in class there. Please let me know if there's any issues. Again, apologize for, I can't, YouTube is YouTube, so, but I'll have this uploaded here soon. I'll have this uploaded soon for you guys to reference. Again, apologize about that. If you have any questions, reach out to me, Google Classroom, or to my email. With that being said, I hope you guys have a good week. I'll talk to you guys soon.